Okay, let's jump right in and talk about the division of polynomials and using synthetic division to divide. First of all, we have a division algorithm, and it'll make more sense when I refresh your memory on what you did in elementary school. Okay, so I'm going to take a break from the division algorithm for just a second, and I'm going to do a little recall. So right down here for recall, let's do something from elementary school like 500. Let's make it a little bit more roomy. Let's suppose we have 536, and let's divide it by 7. All right, so 7 can't go into 5, so nothing for that spot. 7 into 53, I can get as close as 49. Okay, so if you recall, 7 is 49. Also, as you recall from elementary school, you would subtract these two lines. 53 minus 49 is 4. Then we're going to bring down, so that subtraction is 4. And we bring down the 6. 7 into 46, I can get as close as 42. 6 times 7 is 42. We subtract these two lines. We get a 4. I either need to go into decimal territory, or I need to stop and say I have a remainder of 4. Two different ways to write that. So now let's talk about what this means, okay? So what this means is we did 536, we divided it by 7, and we got 76 with a remainder of 4. That is one way to write it. Another interpretation is we could say, well, 536 was equal to 7 times 76. That doesn't get us quite to 536. I'd have to multiply these two, and then I'd have to add 4 more because that was like the leftover, or in other words, the remainder amount. Okay. Another way that we could write this is back to the original division. 536 divided by 7 is equal to 76, and the remaining 4 wasn't able to be divided by 7, so it's a fractional piece that remains. So when doing the division, the quotient is 76 and 4/7. So those are 3 different ways to interpret the answer that we got. Now, if I go up top to the box that I kind of ignored a little bit ago, this is the equivalent of what's here in the f of x box being the 536. These two pieces, the d of x and q of x, is the 7 is the divisor, q is the quotient. That almost got us to 536. I needed to add the remainder of 4 to get there. So that would be the equivalent. We are going to do this exact same thing with polynomials, okay? All right, before we jump to polynomials, let's do one more thing with numbers, okay? Divisor, and we're dividing it by, excuse me, I think I just misspoke, dividend, divisor, let's divide it by 4, and let's see what we get for a quotient, being what's the answer. 4 goes in there 1 time, 1 times 4 is 4, we subtract, bring the 3 down, 4 can't go into 3, so we have a 0. We're going to bring another one down, 4 into 36, that goes in there 9 times. 9 times 4 is 36. We subtract, we get 0. This divides it nicely. The remainder is 0. Okay. When it divides it nicely, again, I'm going to go to the interpretations. We can say 436 divided by 4 is equal to 109. Or we can say 436 is equal to 4 times 109 with a plus 0 for the remainder. We won't bother writing that. Okay, now when this is the case and there is no remainder, remember these are considered factors, right? If you can divide it nicely and you don't get a remainder, they are factors. Keep that in mind. That we'll use that when talking about polynomials. So Again, if it can divide it nicely with no remainder, it's a factor. Okay. Now, come back up to the box here. We're going to do the same thing with polynomials. Okay. So they're saying, hey, we have this polynomial function f of x, and we are going to divide it by d of x. So we're dividing a polynomial out of it. Okay. When they talk about the degree, they're just saying, hey, we're dividing it by something that has a lesser degree, okay, or equivalent degree. All right. And then the answer is what would be the quotient and a remainder if there is one. Okay. So we have it listed here with numbers. We're going to do the same thing with polynomials. All right. With this example right here. And we're going to do long division because that's what you're used to seeing. And then I'm going to show you how to expedite it using synthetic division. So here we're doing f of x divided by g of x. Okay, so if we're doing long division, then under here is the dividend, which is the f of x. So x squared plus 3x plus 2. And we're dividing it by g of x, which is x plus 2. Okay, now it's a little bit different with than it was with the numbers because we have to think about the variable x. Okay, I am going to not really focus on the plus 2. I'm going to focus on what do I need to multiply x by to get to x squared. I need to multiply by x. Okay, so now I multiply those two together. Okay, just like here how we did 7 times 7, I'm going to do x times x plus 2, and I get x squared plus 2x. Now, what did we do with those two lines? If we look up here, we subtracted them. So I'm going to subtract this whole line. I have to be careful now with my signs, right? X squared minus x squared, those are gone. I have a 3x minus 2x. And that's it for the subtracting. And now I bring the plus 2 down. And now I ask ourselves again, what do I need to multiply x by to get to x? Oh, just a plus 1, right? So now we do what we did before. Here we had a 6. We multiplied that by x, and we got our 42. So we're taking our 1, positive 1, multiplying it by x plus 2, and we get x plus 2. And remember, we subtract these two lines. X minus x is gone. 2 minus 2 is also gone, meaning it divided nicely. Remainder is 0. Okay, so here's what we interpret. What did we just do? We just did x squared plus 3x plus 2 divided by x plus 2, and we got a quotient of x plus 1. Another way, if we go back to our different ways we can interpret this, we could say x squared plus 3x plus 2 is equal to x plus 1 times x plus 2, right? Now, there's no remainder, so these are factors. Right? If the remainder is 0, then those two pieces are factors. Okay, now to show you synthetic division, which is just an expedited way to do the long division. Okay, it's kind of slick. So, for synthetic division, here's the setup. We're going to take the dividend, so what's on top, right? I'll write this right here. This is what we're taking, and we're dividing it by x plus 2. Okay, so the coefficients of x squared plus 3x plus 2 are going to be laid out like so. Okay, now the next part is a little bit tricky. It divides it nicely. I mean, we already know that it does, but if it divides it nicely, we'll get a remainder of 0. If I set this equal to 0 and I solve it, I'll get an x-intercept, if you will, or a root of -2. So this is kind of tricky, and I'll explain that more as we progress here, but I'm going to put -2 in a box. The reason being is that whatever we're dividing by, I need to have a minus in front of the box. So if I have x plus 2, that's equivalent to x minus a -2, hence -2 goes in the box. Okay, we'll practice more with that. It's basically the opposite sign that you see. Okay, now here's how synthetic division works. Bring the first number straight down, if this is just a process. Multiply that number by a number in the box. Add them straight down. Multiply by the number in the box. Add them straight down. And the cool part is whatever lands here in the very bottom right corner is the remainder. Okay, we're going to practice synthetic a lot. Okay, not only is that the remainder, but what's left on this row here is the quotient. So what the heck is it saying? It is saying that x squared plus 3x plus 2 divided by x plus 2 is equal to, now this was an x squared, and we're taking an x, so a linear piece out of it, leaving us with 1x plus 1. And that is the quotient, and a remainder of 0, which we don't bother writing. Okay? So that's a remainder of 0. So that's the quotient. An interpretation, x squared 3x plus 2 is equal to, well, it would be that x plus 2 times that x plus 1. Okay? Yes, they're factors because the remainder was 0. So let's just recap. This is a quadratic, and I know your background, you've graphed quadratics. Okay? You didn't get this far in math if you hadn't graphed quadratics. So if we graph quadratics, when we do, we know it makes a parabola. Well, if you can have a factored quadratic and you get these for factors, if we each factor equal to 0, in this case you would get a -2 and a -1. What that tells me is this function f of x, right, since these two factors and their zeros, or in other words, x-intercepts, -1 and 1, probably not pretty, but a parabola that looks similar to this. This would be the f of x function. Probably a little deeper than you want to go, but what I'm trying to get at is that number in the box is what would be the 0 of the polynomial, or at least one of them, right? Okay, let's practice synthetic some more and just know that there's deeper connections. Okay, it looks like this time we're doing f of x divided by k of x. So f of x, recall, was x squared plus 3x plus 2, and we're trying to divide out of it x minus 5. So if I'm going to do synthetic, the number in the box would be a positive 5. Okay, because if we can, this can help us factor, right? If I can factor out an x minus 5, let's see what we would get. Okay, so that would mean the 0 would be a positive 5 in the box. And then we list our coefficients and we follow the process. Okay, here's the process again. First number comes straight down, multiply by the number in the box, add them, multiply by the number in the box, add them. That is the remainder. So here's what I know. I have a remainder, which means it didn't divide nicely, right? I also know that that means that x minus 5 is not a factor because it didn't divide out nicely, right? the quotient was 1x plus 8. But the thing is, my remainder was 42. But if I multiply these two together, I'm going to get that answer. I would have to I would have to add a 42 on the back end in order for it to equal that original polynomial. Okay, so they're not factors. And they're not factors because they didn't divide it nicely. Okay, all right. Well, let's practice this a couple more times. Here you'll notice I have a leading coefficient that's not 1 like the previous examples did. Okay, all right. Let's try synthetic division and try to divide out x minus 3. So that means I put a positive 3 in the box, and my coefficients are 5 minus 3 and a minus 36. So I can think of it as a negative 3 and a negative 36. Real quick note here, if you have a term that doesn't exist, like if this wasn't here at all, I would have to add a 0 as a placeholder when doing synthetic. Okay? All right. Synthetic division. First number straight down, multiply the number in the box, add them, multiply by the number in the box, add them. Very nice. This is my remainder. So I divided 5x squared minus 3x minus 36. I divided x minus 3 out, and my quotient was, it was quadratic. We took a linear out, so what's left is 5x plus 12. Okay, that's how we would write it. This is the quotient. Okay, another interpretation could be, you can divide it out. That means that it was factorable by it, right? That means that x minus 3 times 5x plus 12 were factors. Not only does tell us the factors, but we also know now that 3 is a 0, or x-intercept, and it looks like a negative 12/5 is also an x-intercept, or a 0, right? If you set them equal to 0. All right, let's try this again. This time, the number in the box was going to be a negative 2. Okay, because that would be the factor x plus 2. My leading coefficient is what I'm going to lay out, signs included. So a 4, a 10, a negative 6, and a negative 20. It's the x cubed, x squared, x, and the constant. All right. Bring your first number straight down, multiply by the number in the box, add them, multiply by the number in the box, add them, multiply by the number in the box, add them. This makes me happy. That means it divides out nicely, or in other words, factors out nicely. Okay, so the quotient is right here, 4x squared. Remember, it was cube originally. We took a linear piece out of it. 4x squared plus 2x minus 10 is the quotient. Okay, I could say that this polynomial is equivalent to as a factor and 4x squared plus 2x minus 10 as a factor. And absolutely, we could keep going to see if we could factor this more, right? Or we could find the x-intercepts by setting it equal to 0 and solving it, right? Using quadratic formula or whatnot. All right, so this, though, it says use it to divide. So this is the quotient right here. Just like talking about the interpretation. And this was a cubic function, and I did add in here the graph of it. So we could see that we had negative 2 in the box. It did have a remainder of 0, so it did divide out nicely or factor out nicely, which actually means that we have the function has an x-intercept at negative 2. Now, if you're zoomed out, it looks really misleading. There is another x-intercept there, and then obviously 1 on the other side of the y-axis. So, all right. Let's go back and keep moving here. We're going to go again. This time we're going to divide by x minus 1. So that means that positive 1 is in the box. And that would be the factor, if it does factor out, x minus 1. All right, coefficients, negative 9, 10, 7. Notice I don't have an x term, so I need a placeholder. That's 0. And then the constant of negative 6. Straight down, multiply, add, multiply, add. Oh, come on. Multiply, add, multiply, add. So what does this tell us? This tells us that 1, it tells us x minus 1 is not a factor. It tells us the remainder is 2. Okay. And it tells us the quotient. So basically, this function, negative 9, the original one here, negative 9x to the 4th plus 10x cubed plus 7x squared minus 6 is equal to, we tried to factor out x minus 1. What we got was negative 9x cubed, I'm looking here now at this row, plus x plus 8x plus 8. That doesn't quite equal the original function. I have to add the remainder on the back end for it to equal. So it didn't divide it nicely. All right. Let's see here. What do we do if we're trying to divide and this has a 3 in front of it? What's the number in the box? Well, I can't put just I can't put just 2 in the box. It doesn't work that way, right? So there's a couple different ways to do this. We can jump ship on synthetic division, and we could go to, try to go to long polynomial division, which we did. You could certainly do that. Or I'm going to consider not this, but what if I consider this instead? They have the same x-intercept, right? So if I try to divide by x minus 2/3, I might have success because that leading coefficient here is a 1, okay? I can't do synthetic division when this has a 3 in front of it, okay? So I'm going to do the synthetic with this, okay? All right, so that means 2/3 go in the box. Coefficient is, coefficient row, 6, 11, negative 31, 15. Process. Bring the first number straight down. Multiply by the number in the box. We're going to get 12/3, which is 4. Add. Multiply by the number in the box. 30 over 3, which is 10. Oops, 10. Add. Multiply by the number in the box. We'll put negative 14. We add, and we got a 1. So that doesn't factor out nicely. So you do not have an x-intercept at 2/3. And you do not have x minus 2/3 as a factor, nor will you have 3x minus 2 as a factor, okay? What you do have is 6x cubed plus 11x squared minus 31x plus 15, original polynomial. I tried to divide out in x minus 2/3. What I got when I did that was 6x squared plus 15x minus 21. But then at the back end here, I'd have to add a remainder of 1 to it to get it to actually be equal. Now, if I want this term instead, I'm going to take a 3 out of this and put it with the other one. So if I take a 3 out here, like factor 3 out, I'll get 3 times 2x squared plus 5x minus 7. There's still the plus 1 in the back. And then I have x minus 2/3. If I distribute the 3, I'm going to have my 3x minus 2. So that would be the only way to make that adjustment. Okay? It's not a factor, so it's not something we're going to have to dig deeper into. If my remainder was 0, absolutely I would want to continue to try to factor it to find all of the zeros or all of the factors that we have involved here. Okay, all right. I'm getting near the end of my time, so let's wrap up with one last quick question. The volume of a rectangular solid is given by this polynomial. Well, volume of a rectangular solid. Think about this for a second. Volume is length, width, height. Okay? It's telling us that the volume is 3x to the 4th minus 3x cubed minus 33x squared plus 54x. That's the volume. They're telling us that the length is 3x, the width x minus 2, and the height, they want us to solve for t. So first things first, I'm going to take this polynomial. I'm going to divide by 3x. And then I'll divide by x minus 2. Actually, you know what? Dividing by 3x is going to be kind of easy here. If I decide the x's are gone, do it here, but each one of those is divisible by 3x. So that actually is going to kindly make this minus squared plus x 30 and 24, 10, 18. Okay. And that's equal to, we divided the 3x, so now it's equal to x minus 2 times t. And I'm trying to solve for t. So now we'll divide by x minus 2. That'll give me t. So to divide this, I can do synthetic division or long division. I'm going to do synthetic. 2 goes in the box. 1, negative 1, negative 11, and 18. Like that. Remainder is 0, which means the only thing left is on this side is t. Come on. T. There we go. It's very, my screen's very sensitive. Okay, so t will equal, and then what did I get when I divided those? I got this quotient right here. It was cubic. I took a linear piece out of it, so now I've got 1x 9. That. This is the height. And we're done. Hopefully that made sense.